We have here example number 2 under topic 6, torsion. So we need to determine the maximum torque that can be applied to a hollow circular steel shaft of 100 mm outside diameter and an 80 mm inside diameter without exceeding first the shearing stress of 60 megapascal and or a angle of twist of 0.5 degree per meter. We need to use the shear modulus of equals to 83 gigapascal. So first condition, we need not to exceed to the maximum shearing stress, which is 60 MPa or Newton per square millimeter. Next one, we have here the angle of twist, which is simply or must be equal to or less than 0.5 degree per meter. So remember, this is a hollow circular steel shaft. So there is an available formula for that one, for the polar moment of inertia. So first we need to solve for under the first condition. For the maximum shearing stress here, it is given on the previous video that the formula for this one is simply 16 times the torque times the outside diameter all over pi times the difference of the outside diameter to the fourth minus the inside diameter to the fourth. So our maximum shearing stress is 60 MPa times 16. We need to solve for the torque or the maximum torque times the outside diameter of 100 mm all over pi times 100 to the fourth minus 80 to the fourth. So our torque here is 6,955,486.14 Newton millimeter or 6,955.5 Newton meter. And next we need to solve for our torque based on the maximum angle of twist, which is 0.5 degrees per meter. So our formula here is simply the torque times the length of the shaft all over the polar moment of inertia and the shear modulus. So we have here 0.5 degree per meter. So we need to convert this into radian. Pi over 180 equals to the torque times its length, which is how much? So since we are given 0.5 degrees per meter, so we need to assume that our length here is simply 1 meter or 1000 millimeter. So that is 1000 all over our J, and we already know that the formula for the polar moment of inertia is pi over 32 times the differences between the outer diameter to the fourth minus the inside diameter to the fourth times the shear modulus of 83 gigapascal, since we are going to make sure that the unit is still the same all throughout the solution. So we need to multiply this by 1000 to make this an MPa. So our torque here is 4,198,282.97 Newton millimeter, or simply 4,198.28 Newton meter. So since we are solving here for the force or simply the torque and not any dimension, so we need to choose the lesser value. So in between the two, so we need to choose the torque based on the limit of the angular twist, which is 0.5 degrees per meter. Why? Because this is not a dimension. And also another explanation is if we substitute this value here, then our answer will not go beyond the maximum shearing stress of 60 MPa. However, If we choose this answer and we substitute this to the t here, then our answer is not anymore 0.5 degrees per meter or lesser. We go beyond the limit of the angular twist, which is 0.5 degrees per meter. So again, on the previous video, since we are solving there the dimension, we need to make sure to use the bigger value. However, if we solve for the forces or the torque or the moment, we need to use the smaller value. So our final answer here is the maximum torque for this hollow circular steel shaft is 4,198.28 Newton meter.